Hi everyone, I'm Elaine from C Studio, the marketing manager. Today I'm so happy to invite Chris from Explaining Computer channel and to share with us about some SBC market. And also today we especially bring up our ODYSSEY X86 V2 boards. So that board is picked as his favorite SBC in 2022. So this time we have upgraded some features and also interfaces. So today we're going to show up that. So before we get started, so I will have a quick introduction about Seed and what about, let's quickly have an introduction about Lakshantha and also the Chris.
Thank you, Elaine, for the introduction. So I'm Lakshantha, and I'm an application engineer at Seed Studio. So my main areas of focus are IoT, embedded systems, and AI. So it's I'm really happy to be a part of today's discussion with Chris, and I hope you guys will enjoy this journey together with us. Over to you, Chris.
Well, thank you very much. Well, it's good to meet you both this morning and to meet everyone else watching us out there on the internet. I'm Chris Barnatt. I run the YouTube channel Explaining Computers, which covers all sorts of things linked to computers, but there's a lot of videos about single board computers, about SBCs. I spent most of my career as an academic. I still work as a sort of freelance academic, but these days, most of my time I spend making videos on YouTube.
Okay, cool. Thank you, Chris. I'm looking forward to this discussion, especially that this end of this year. Yeah. So as Seed, we are striving to be serving the global developer community since 2008. We are NVIDIA preferred partner and also Raspberry Pi design partner. So that's we also bring a lot of full systems and SBCs around Raspberry Pi and also the NVIDIA Jetson. So with Shenzhen's vast resources and trusted technology, distribution partners around the world, we are strive to be the most integrated platform and creating the hardware solutions for IoT, Edge AI, and also the AIoT applications. So ODYSSEY, actually we released the ODYSSEY X86 in very late 2019. So that is a quad-core Intel Celeron J4 135 boards and with Arduino coprocessor. So this year we upgraded into X86 V2. So what we upgraded is we changed the coprocessor to RP2040, and we also encrypting the dual 2.5 gigabyte Ethernet. And also we have the reservable i3 or i5. It comes with dual 2.5 gigabyte Ethernet and also M.2 B key and E key for extensions. And what is more special, that is comes with the dual SATA to extend more storage. So for the Jetson product line, we also have the reservable. It's kind of the similar design as the reservable of the i3 with a hybrid network connectivity and also the local storage to bring more the local storage power and also working with the powerful NVIDIA Jetson SOMs. And we also have the reComputer. It's a small edge box. It comes with Jetson Nano, Xavier NX, and also the upcoming the Orin NX SOM. So it is aiming for the edge AI applications across different industries and autonomous machines. So Raspberry Pi CM4 as a Raspberry Pi official design partner. So last year we bring the read terminal, that is a next generation of the HMI. It comes with the touch screen, and also in the back we have the extension boards, comes with some industrial and also other usable interfaces. And also with router, it comes with is the dual gigabyte Ethernet and dual USB 3. It's a perfect device to set up a home software router because it's pre-installed OpenWRT. So this is a short glimpse of the RISCV families. So I will turn the question to Chris. So what do you think the most compelling the feature of the ODYSSEY boards? Because you picked it as the most the like sports in 2020. Yeah, so I want to know how do you think about that?
Great. Well, I think for me, one of the things like, and I've got a board here. Look, here's this is the first generation. I think this is a J4105 board, and the thing I like about this board is because it's a X86 based board, so it means unlike many SBCs which are ARM based, you can run anything on it. You can run Windows, you can run Linux, you can run FreeBSD, you can run Chrome OS Flex, all sorts of things. And the thing I particularly use this for, because I make a lot of videos on this channel about single board computers, as you know. But I also use single board computers to make other videos. And this board has been used in more videos, I think, with any other than the Raspberry Pi behind the scenes. And for me, it's because the storage options are so good on this. You can just flick off the top. I can find a little thing there, as you know, and just flick it off like that. And we can get straight in, and there's 2 slots for M.2 SSDs, and there's a SATA port as well. So it's very easy with this board to go, I just need to check out an operating system. I can just drop in a drive, not necessarily even in the case, plug it in, select it in the BIOS, use it, come back again. And although there are other small form factor boards of this sort of size around, they don't tend to have that connectivity when it comes to multiple drives and options. And for me, that's something that makes a big difference. And this is why most of my single board computers are packed away in boxes just over there, and they're hard to find. This one's always at the front because I'm often getting it out to do something, and it's because of that storage and because it's x86.
Wonderful. So besides the storage, what do you think a must-have the functions for a SBCs? Do you think that is very crucial for the customer when they're gonna buy that for a home lab application?
I think with an SBC, it depends greatly on the use. I would split into sort of 3 categories, really. I think there are industrial buyers, and industrial buyers are often thinking of one specific application, and they don't mind doing a bit of development work for that application. They want to put it in a particular place. And industrial buyers, obviously everyone wants a certain spec of processor and memory for whatever their application is going to be. But industrial buyers think about reliability a great deal. They think about energy efficiency. They think about long-term availability, because if you're going to build an SBC into, say, a piece of production line equipment or into a product, you've got to know you can keep buying it. And that's one of the reasons why the Raspberry Pi has hung around so long. People don't tend to realize this, but the Raspberry Pi, you can still buy a Raspberry Pi 2. And people therefore can know they can keep for a long period of time. So industrial buyers, it's reliability, it's some of the practical things like energy efficiency and its availability. I think for makers and enthusiasts, it's somewhat different. And there, some people want to buy a board for a particular use, as you said. So maybe they want to build a home lab, maybe they want to build their own router, maybe they want to build a robot with vision recognition. Those have all got different particular requirements. If you want to build a robot with vision recognition, you need camera ports, you need good, either a powerful GPU that can handle the machine learning, or you need an MPU or something like that. But I think for a lot of enthusiasts and makers, and many of the people who watch my channel who are interested in SBCs, are there because an SBC is a hobby. They're interested in it. They like to be able to experiment with computing. They're there for educational reasons. They're there because they just enjoy having a board, and they're interested in owning it the same way people have interest in all types of things. And for them, I think the 2 things that matter most are, first of all, the support around the board and the availability of software. And that's why sometimes if you go for something like an x86 based board, of course, you don't have any worries about supporting software because it'll run everything. Whereas a lot of ARM-based SBCs, and I'm sure you've seen this on the channel, you can go, this is a fantastic piece of hardware, but if it hasn't got the software support, if you're not an industrial developer who can spend time doing something about that, makers don't want that. And I think the other thing for makers is price. Makers are very price sensitive. I think a lot of the SBC community has grown up since the launch of the Raspberry Pi. We had single board computers before the Raspberry Pi, the Beagle board, and all sorts of things before that. But the Raspberry Pi created a type of market, and that was a market for people who wanted to buy a relatively cheap device which they could experiment with. When the Raspberry Pi was first launched, they said one of the reasons for it is people should be able to experiment with computers, because back in the 1980s and in these early days of microcomputing, as we called it then, you could code your own programs. You had a lot of really close contact with the hardware and the software. And today, if you have a PC or a laptop or a tablet or something, that's completely abstracted from you. You can't really experiment with it. And what the Raspberry Pi did was to say, let's have a board where you can see it, you can program it, you can plug things in. And that, I think, is what enthusiasts go for. And I think for them, the price is a critical part of it, as well as support.
Can you elaborate more about, you mentioned the software support, is that for a hardware manufacturer, so they should offer a comprehensive the BSP support, or like they should we're aware of the multiple software support, like the software application support and offering the tutorials. Yeah.
I think it's a bit of a mix of that. I think for most people, when they're buying a board, certainly the maker, the enthusiast market, what they really want to make sure is there is one really stable and reliable operating system image. I think often manufacturers go, oh, you can get 12 different Linux distros for our ARM-based board. And actually, people don't really care about that. They say, is the one that really works well? Is the one that's got, for example, access to GPU accelerated video playback, which there often isn't on an ARM-based board. So I think most people, the whole Linux community has become about breadth, number of distros and number of applications, but actually it's whether something works that worries people. Have they got the libraries? Are there the drivers for the Wi-Fi on the board and to accessing SSDs? There's a lot of SBCs out there with very poor software support, ARM-based SBCs. You don't get the problem with X86-based boards, of course, because it's a much more stable platform. That said, I think what you just said on the end there is also very important, in that educational resources matter. People, if they want to get into being a maker, they probably don't have, in all cases, a computer science background. There are people who buy an SBC and they've been into computing all their lives, and maybe studied it at college or school or something, and they know about how to make stuff work. But a lot of people don't. And a lot of what I do on my channel is to bring things to people where some people are sitting there in the comments going, well, everybody knows that. And in fact, they don't. Most people know very little about computing in terms of the technical stuff. And therefore, everything that supports people in terms of clear documentation, tutorials and things, that again is important, because going back to my point, if someone buys a board because they're a hobbyist, they want to experiment, they want to do projects, they want to know, how do I make this bit work? How do I make that bit work? Where do I get a driver from? Where can I check I've got my wiring right? So having tutorials and things available is I think, a really important part of supporting an SBC community. And if you support a community, you tend to do well with the board.
Yes, I agree. That is, so the board manufacturer should keep offering the stable the software, but in the other side, so for just grow up with the maker, it has to comes with the different tutorials, and especially the end-to-end tutorials. I think that is we can just turn to the Lakshantha. Lakshantha have built a lot of the ODYSSEYs, the tutorials. Yeah. So Lakshantha, what about that? And what's the most applications you like for the ODYSSEY boards?
Yeah, I think, I agree with Chris, what he told. So actually, even for the ODYSSEY boards, I have been doing a lot of wiki tutorials for the ODYSSEY boards, especially the ODYSSEY board that Chris showed a few minutes ago. So there are different kinds of application tutorials that I have done. Maybe I can share my screen and show and go through some of the tutorials that are written for the ODYSSEY X86 board. So actually, this is the main wiki for the ODYSSEY X86 board, the J4105 board that Chris mentioned before, and we have the basic getting started guide, starting with the specifications and like how you can easily get it up and running by following this wiki tutorial, like how you can install the operating system, like you can use the USB, like all these steps you can find in this wiki. And apart from the basic getting started, so this is the basic getting started wiki. So apart from the basic getting started wiki, we also have wikis such as how to install Home Assistant, you see. So this is a small wiki tutorial on how to run Home Assistant on the X86. So because we have realized that you can have a lot of applications running on an X86 SBC, as Chris mentioned before. So we have different applications, and we offer like step-by-step tutorials on how to build each of those applications. So this is the Home Assistant, and if you go here, there's another wiki which explains how to install a media server on the X86 board. You can install OpenWRT. So so as you can see, there are a lot of getting started tutorials on how to build different applications. You can have the pfSense. You can use the ODYSSEY X86 as a pfSense router. Also TrueNAS. You can convert the ODYSSEY X86 into network attached storage. As like Chris showed before, like the X86 board has a lot of storage options with the M.2 slots and the SATA ports. So it can really make this board suitable for NAS applications. So you can easily go through these documentations. It's very friendly for the beginners as well. Like you don't need to know about what NAS is. Like if you go through these wikis, you can simply understand. Yeah, exactly.
Yes.
Yeah. So that's pretty much about the
Yes, and especially we have engineers, a lot of engineers. It's just right now it's using the reservoir or the ODYSSEY. It can become a must-have box on their desk, and they're using the TrueNAS because TrueNAS is a very friendly use and open source project. Yeah.
I built a NAS on this board. I can't remember. There's a video about I did that somewhere. I think it was TrueNAS. I can't remember. It might have been FreeNAS before it all changed over. But
Yes,
I do.
They changed it.
Yes, yes. I do remember looking at your. I didn't know you'd written them, but I looked at many of your guides, and they are very clear, as you say. And it is, you don't want someone to buy a board and then suddenly go, I've got a piece of hardware. What do I do? You know, there's no point having all the connectivity if you haven't got support for it. And I think it's good to see that you have a lot of support. You know, and people, they can take a piece of hardware and then they can do things with it and they can make it happen. And also in the process of that, they're learning about stuff as well, because it isn't just about saying press this button, it's there. People are going to put some effort in, learn it, and therefore their understanding of computing changes. And their appreciation of what they're doing changes. I think that's important as well. It's an educational journey for people.
Yeah, and one more thing. So even though we manufactured this board quite some time ago, we still bring the tutorials for the different applications for the board, right? So we continue to push a lot of content around the board, even though the board was manufactured some time ago. Yeah, I think that is important. Like we try to stay with the market, stay with the technology, and when the new technology comes out, we try to experiment those new software technologies on these boards.
Yeah. Yes, we can
cover
them at one time. You go.
Yeah,
please.
And that's about how you maintain community as well, because I think it's very obvious to customers if they see that you support a board for a few months and then it all falls away again. You know, I think people are becoming much more aware of that. You know, the SBC hobbyist community has built up very rapidly over the past 5 or 6 years, and early on, I think people weren't aware of so much of these issues of what happened to support over time. But now they're very aware of what you say. They want to see that you're, as a manufacturer, staying with them. You know, that's important.
Oh yeah, Chris. So actually the ODYSSEY Blue you have that is with the keys, but we have seen many the bare boards. So do you when you buy a SBC, do you prefer with keys or without keys?
I think it's good to have a case available. I suppose in general, when I'm making a video, I like a board without a case, because if it's got a case, I'm going to be taking it apart to show that the board anyway. So I think it also depends on the cost of the board. I think if you've got a board like this, which is up at the sort of towards the price of a mini PC, you do expect to have a case available, because it's going to be, as you just described, people have it on their desk, using it that way. If you've got a much cheaper SBC, then it's probably going to be used in a more project setting like a Pi, and therefore I think the case becomes less important, which isn't what to say some people don't want one, but I think I guess I'm saying it's the option. I wouldn't like to see an SBC you couldn't buy without the case, because sometimes you don't need that. But I think having the option is clearly a good thing. I like the way you've developed this case. I've forgotten what the case is called, but you use it for several different boards, don't you? And I think that's a very clever approach. You can get this. This has got the X86 board inside, but you can also have a Jetson Nano inside or a Pi inside, which is a clever bit of planning.
Yes, it can fit Raspberry Pi and BeagleBone, and also X86 boards. Yeah. So actually, ODYSSEY V2 that is also comes with the two versions. So one is bare board, and another one is with the same blue case. So Lakshantha, do you want to show up the how is the interfaces looks like for the ODYSSEY V2?
Yeah, sure, Ellen. I'm very excited to show you the latest V2 version of the X86 board today. So here I have with me that board. So this is actually the ODYSSEY X86, as you can see, the J4125 V2. So the one which Chris showed was the J4105, and actually this is the upgraded chip, which is the J4125 chip, and we have some updates on this board. So as you can see, it has the same number of Ethernet ports, but we upgraded to 2.5 gigabit Ethernet for both the ports, because before we have only 1 gigabit Ethernet for the two network ports. And apart from that, there's a TPM firmware TPM module inside the CPU, right? So if TPM, and which means you can install Windows 11 on this board, because as we all know, like I don't really know why they have this kind of requirement for Windows 11. Maybe Chris knows more about it. Do you have any ideas like why Windows 11?
I think
want the TPM.
I think Microsoft is a law unto themselves, isn't it? I think the problem is Microsoft is so focused on part of the industrial, the corporate market, it forgets that Windows is used by so many people. There should be different versions for different markets, but they aren't. So it's and the strange thing is, of course, if you need to, you can hack Windows 11 onto everything. It's much better if you've got the modules you just described. But what will Microsoft do next? It has been a complete disaster the way they've rolled out Windows 11 in terms of this support issue, and at least you've done what you can to support it on the board in the easiest possible way. But you never know what Microsoft will do next.
So for now, it can support the Windows 11 because of the firmware TPM on the board. So when you buy this board, it comes with the Windows 11 Pro already installed, right? It's so there are different versions of this board when you try to buy it. It comes with the onboard eMMC 64 GB version, and it comes without the eMMC, and also it comes with the activated version of Windows Pro, and also the unactivated versions of Windows Pro. So we offer like different versions to suit the price range for different customers, because maybe they don't want to spend a lot of money for the activated version of the Windows Pro 11 Pro, right? So he would go for the unactivated version, and also for the eMMC, the 64 GB eMMC. Maybe they just want to boot it from the M.2 slot over here, just plug in SSD and boot the Windows. So in that case, they don't need the eMMC, right? So we offer a lot of options, and also like talking more about this board. So it has got the same 3 SATA ports on the board over here for the hard disks, and this is actually the SATA power, and this is the data for the SATA drives. And also, what else do we have here? Let me see. Okay. And also, it has got a external TPM option. So if you want, because on board it got the firmware TPM, but if you want to have a hardware TPM, right? So you can plug in an external TPM over here. We have a header reserved for that, because maybe some customers would want to have this kind of TPM functionality. Like maybe like is Chris aware of like industries who want to rely on the hardware TPM modules on an SPC? Do you have any
there are
thoughts on this?
certainly there are certainly companies who want to go to the absolute pinnacle of security, and therefore they would want that option. So it's you've got the flexibility there, haven't you? Which is a good thing. And one of the things you didn't mention, the eMMC, that I like, I presume is still the case. You can turn it on and off in the BIOS, can't you? Can you presume you can still do that? So it means you can, if you want to boot, say, from Windows on that board, you can, but you can then turn off eMMC, install, say, a Linux distro without disturbing Windows, without Linux getting so keen about installing a grub menu on it. So it's great to have the options of. It's just a really flexible board.
Exactly. And like talking a little more about it. So we changed the core processor to the RP2040, which released recently, but the one which released by Raspberry Pi. We put it over there because before the board that you have on your hand, it has like ATSAM D51 my core processor. Because there are some users who want to play around with the GPIO over here, right? So they want to maybe like build some Arduino applications using the SPC. They can connect some sensors to it, some temperature sensors, humidity sensors, or like different kinds of environmental and other kinds of sensors. You can connect to these headers, and also it got the same 40 pin Raspberry Pi header over here. It can be accessed through Linux once you install Linux on it. And also it got this Type-C connector. This one, the Type-C connector. It supports DP output as well to connect to an external display. And it got an HDMI 2.0 port over here, HDMI 2.0, and two USB 2.0 ports, and one 3.1 USB 3.1 port over here. And apart from that, it got the same M.2 slots, one over here and another over here, just like the board that Chris showed before. And also it got what else? Oh yeah, it got this one. It got two slots over here, one for micro SD cards, and another one for the SIM cards. So you can have like a 4G connectivity on the board. But even though you put a SIM card inside this slot, you cannot have the 4G connectivity because you want to install another 4G module, the M.2 4G module over here, so that you can have the 4G connectivity. I think this is a very interesting feature of this board, because like there could be some places where you don't have a Wi-Fi or you don't have the Ethernet connectivity with this board, so you can simply use the 4G connectivity, to get the network up and connected with the board. So it got the RTC. You can see this one. It's just over here. You can just paste it. There's like a 3M. I didn't paste it, so you can paste it over here. The RTC. Yeah, I think. And what else? Yeah. Finally,
can I ask?
Yeah, sure, Chris.
I'm going to say, the M.2 slots, are they still one SATA and one NVMe? So you've got the choice.
Oh, yes. Yeah. So one SATA and one NVMe. Yeah.
And that means you can, I presume, still add on a board into the SATA slot, so you could have extra SATA ports that way. So you could have, say, a couple of SATA ports off that M.2 slot. So if you wanted to have lots of SATA ports on it for drives, you can do that. It can. Exactly.
Yeah. But I want to mention one thing over here. It's good thing that you bring this point out. So we have one SATA board over here, and once you install another M.2 adapter, right? M.2 to SATA adapter. So that we sell that kind of adapter on our website. So we have one adapter for like 5 SATA ports max. But the thing is, that's the maximum one we have, 5 SATA. But the thing is, when you use SATA with this board, one thing that we need to be careful is the power requirements, right? Because the hard disk draw a lot of power, and when the maximum number of hard disks that you can use with this board is 2 drives. When you connect the power, when you power the board with this connector, because you can input maximum of 12 volt at 3 amperes, so that's the maximum. At 3 amperes, it can function the board properly, and 2 hard drives at the same time. But when you have another adapter, M.2 SATA adapter, and you connect more than 2 hard drives, in that case, you have to have another external power adapter to power the hard drives. Yeah. So this is something that I want to mention here, because
Yes.
there are some users where they would just connect all the hard drives together and just power it, and they will say, "Oh, it's not working. So why
Yes.
is the board broken?" So we need to tell this to everyone. Yeah.
That is true. I imagine you'd be okay with multiple SSDs of that sort of thing, but just not a spinning drive.
Exactly. Yes. Yes. You're right. Yeah. We can have multiple SSDs for sure. For sure. Yeah. And also it got the same heat sink, a big, very big heat sink, as you can see, with the fan over here, and it's really helpful to cool down the CPU when you're running heavy tasks. So yeah, that's basically about it for this board. And so Chris, so what do you think about this board after?
It looks very exciting. I mean, as I said, I like this board, and it's just adding a bit more power, a new processor. I'm particularly interested in the fact you put the RP2040 on. That's because clearly RP2040 and all the Pico stuff around it is becoming really big in the maker community. And the fact you've got it on an x86 board, I think that a lot of people find that very interesting. It's I'm looking forward to seeing how that works, which I guess brings me back. You'll be writing tutorials on that, I imagine, how we can access the RP2040 functionality on the board.
For sure. Like
yes,
mainly, I think yes, yeah. So mainly, it's going to work out like this. So you can install like Windows or like Linux or any operating system on this board. And then after that, you can just fire up the Arduino IDE, and the Arduino IDE is just going to show the connected board as RP2040, just like that. It's just like you connect RP2040 to your PC, and it recognizes through the serial connection as a RP2040 board. So similarly, it will recognize directly from the Arduino IDE running inside the board. Yeah, which is pretty interesting.
So from a user's point of view, it's like having this and say a Raspberry Pi Pico connected. It just happens to be on one piece of hardware. That's
exactly.
That's very interesting. I think a lot of people will want to experiment with that.
Yeah. And RP2040 is much friendly. I mean, the adding a Arduino processor is just good for makers. Yeah, that is a special feature for ODYSSEY boards. So we discussed a lot about for makers those projects, and also for home labs, the router, media box, home assistant, and also PF Sense, and also the routers. Yeah. So I want to know for the SBCs, Chris, did you see any industrial use?
Yeah, I mean, very much. One of the interesting things about the SBC marketplace is that I think a lot of people who've got into it as makers and enthusiasts, they aren't really aware how much SBCs are used in industry. You know, I was talking yesterday to Evan Upton, who runs Raspberry Pi, and he was saying, it's many years ago the industrial users of that board massively outnumbered the sales into the consumer market. And so Raspberry Pis are all over the place, and other SBCs that, they're in factories helping with automation. They're doing things like digital signage. If you happen to be on a railway station or in a shop and you see a display, something's got to be running it. And that often is an SBC, because SBCs are good for that. They're small, low power devices, relatively cheap. You can stick them anywhere. You can connect them to lots of displays. And so that sort of stuff is done with them. Things like edge computing. If you want to have a bit of computing power alongside sensors, particularly say cameras, and you want to be doing some of the processing where the camera is, then an SBC is great for that. So rather than having a camera feed being put across your network, which is a lot of traffic if you've got lots of cameras, you could actually have an SBC connected to a camera, running a bit of machine learning to do some basic vision recognition, and just sending some data back on what it's identifying, rather than transmitting all that data. So edge computing is a big area of using SBCs, pushing computer power to where sensors, to where devices are. And we also see SBCs inside a lot of products, things like some of the virtual assistants you can buy inside them have got a Raspberry Pi board. Some of the even sort of the routing the network devices have got an SBC inside them. Robots and things people build have got SBCs inside them. Tracking technology, footfall technology in stores, measuring how many people coming in and out. There's an SBC somewhere gathering that data. So it's amazing. I think most people will be surprised that around them in the world, there are often SBCs here and there, which are just gathering bits of data, transmitting bits of data, helping in automation in factories and things, because computer power is useful in so many places, and that boards that can offer it reliably, cheaply, in a small form factor are very good for that. You don't want to be installing lots of big PCs to do relatively small processing tasks, and that's what SBCs are really good for in industry.
Yes, I do agree. That is just the different form factors are just working on this digital transformation across the industries. Yeah. So yeah.
I think I would like to add something here. So what do you think about the form factors? Because Elaine just mentioned that word form factor. So because there are different form factors, right? You have the different sizes of the boards. So do you think that
the large, the
right?
large,
So do you think the form factor really plays a big role when it comes to deploying in different applications?
I think it depends on the application. If you're making a product and you want to put an SBC inside it, then clearly the form factor might be critical if it wants to be a very small product. But and if you're building something that's like a robot, then often you want something very small and very light, because the robot itself, if it's going to be a small robot, you don't want a massive board on top of it. But I think a lot of the time, whether you've got something, this size or this size, doesn't really make a lot of difference, because in many industrial situations and in many maker projects as well, there's room for that, or certainly that without the case, and there's room for that. So actually, there are certain applications where the size really matters, and they tend to also be the ones where things like energy efficiency really matters as well. But providing a board that isn't that big, something the size of a standard PC motherboard is too big for many applications to fit in. But I think a lot of the time it is the power use, the ease of use, and the price, which is far more important than the actual size of the board. And I think it's interesting that we're starting to see a lot more use of the Pico ITX form factor, which is about 80% larger.
Actually, I haven't. Oh, I didn't see it before. Okay, yeah.
So that's the one I want to ask. Yeah, what do you see the difference, like that form factor, other than the ODYSSEYs that size? Because the ITX seems much bigger than the motherboard.
Yes, the Pico ITX. Pico ITX is about the same size as a. It's the one they're using on the Rock 5B at the moment, so it's a bit bigger than a Raspberry Pi. It's the same one they used on the Vision 5 boards from Star5 as well. So its big advantage is it puts all of the connectors on one edge. And so in terms of size, it's probably between those two. It's bigger than the Raspberry Pi. It's smaller than the ODYSSEY boards. But the thing it does is bring all the connectivity in one place. And I think that's often can be a problem. When you've got something like a Raspberry Pi and you're designing something around it, you've got connectivity here, you've got connectivity there, you've got GPIO over there, you've got the camera there. For a designer, that's quite tricky. Whereas for a designer, if you've got all the connectivity on one edge, it makes your life designing it a bit easier. So I think, I hadn't really thought of it that way before, but form factor is not just about the size, it's about the practicality of how you can use it. And that's why things like the Jetson Nano, where you plug it into a carrier board, but you can make your own carrier if you wanted to, or the compute modules for the Raspberry Pi, they also offer flexibility. So for the designers, the form factor works in a very particular way.
Back to the Raspberry Pi and the Jetson. So what do you see the difference between these three boards, or what the difference do you see the ARM SBCs and x86 SBCs?
I think that they sit at different points in the market. I mean, for me, in some ways, I'll go back to the Pi and this board again, but they're almost the spectrum. For a lot of maker use and for some industrial use, the Raspberry Pi, it's a low-cost board, at least if you buy it in the right place these days. you haven't got as much power, but you've got enough power for lots of different things. And you've got a lot of support. Whereas if you want to have x86 functionality, a lot more support, when you go to a board like this, people sometimes say to me, why would you buy an ODYSSEY board when you could buy, say, an Intel NUC or a Gigabyte Bricks or something like that, which is a similar size? And there's two answers to that. One is people often compare this to a NUC or a Bricks board without any memory. And when you remind them they've got to buy the memory, they realize this is actually a cheaper product, but people tend to forget things like that. But also, we're back to things like the storage. You know, some of the other mini PCs around just don't have that flexibility. They've got one slot for a drive and that's it. So I think if you're a maker and you want a powerful board with lots and lots of connectivity, then that gives you everything. If you want to do a more constrained project, you go towards something like a Raspberry Pi. So I think they give you the different ends in the market, and they both got their place. I think in terms of the Jetson stuff, that's an interesting one, because NVIDIA have put them out clearly for artificial intelligence. That's what they sell the NVIDIA, the Jetson boards for. They've got the onboard CUDA cores so they can run machine learning applications, because so much machine learning has been optimized to run on CUDA cores. And if you haven't got an NVIDIA board, you can't run stuff, or at least you can't run it near as easily. I find it.
I want to add something there to you. So when you mentioned about CUDA cores, I think NVIDIA really focused on the TensorRT for the Jetson, right? So the TensorRT has really played a big part on deploying the edge AI applications on such a small platform. Yeah.
Yes, and they've really kept that hardware purely about doing that. That's all that it's for. I've had conversations with people in NVIDIA about this board a year or two ago, and said, you know, you should release some drivers so we can use those CUDA cores in terms of a GPU, not just using them for AI purposes. And they still haven't done that, and it's a great shame, because the Jetson board potentially could be absolutely massive. It's a successful board already. It's very good for the AI applications they support it for. They do a lot of tutorials around that as well. They're very good at supporting it. But it is a board I always feel could be doing even more in the market if they wanted to, if they just provided the drivers. But with NVIDIA, as we know more broadly, NVIDIA and drivers has always been an issue. They like to support certain things. But, you know, you could do some fantastic, you know, you could do a little bit of video editing on a Jetson Nano if they just enable GPU access to the CUDA cores, but they haven't. But maybe they will one day.
Yeah, right. So that is a good feedback. So
maybe they will watch this video and take your recommendation.
Yes,
yeah, they should unleash the full power of their GPU.
That's exactly it. They are not unleashing the full power, and they must be able to do it, because they've got a lot of people who could write that stuff. It must be possible. They've made a conscious decision to decide this is a board for AI in a very particular platform, as you say, and that's it. But I think the maker community.
Talking about the Jetson, I think I would like to show you the reComputer Jetson. So again, just showcase. So as Chris mentioned, so Chris showed the reComputer before, right? The reComputer J4105. So so it's using the same case, the same enclosure, but what we do is we put this one, right? So it got like yeah. So basically we manufacture this carrier board and we put the system on module on it. We from NVIDIA themselves.
The production module.
Yes, the production module with the eMMC, right? And this is the carrier board that we manufacture, and this is a one reComputer. So we have an entire product line of the reComputer Jetson. Powered by NVIDIA Jetson Nano, Jetson XAV NX, and now the Jetson Orin NX, which will be released very soon. So a lot of things are coming out in 2023.
Yes.
Yeah. So back to the driver, I'm curious. So if the almost all the in the some necessary drivers is unleashed. So I want to know for the Jetson, what kind of other application it can be used, like combining the full CPU and the GPU.
I suppose it takes it towards a lot of ARM SBCs are handicapped by their GPU. I think that's the place to start with this. And the Jetson, of course, doesn't need to be. The Jetson has got more potential power. Well, it has got more GPU power than any other ARM board at that sort of price bracket. And it's, it would be great if we could use it for a bit more, little bits of 3D work, little bits of video processing work. It would, I think, given the price of the board and what we know is on it, it just frustrates makers that they can't use that, and often with an ARM board, you're going, as we've discussed already, if there isn't support because manufacturers just haven't got the time or the inclination to make it available. That can't be the case with NVIDIA. NVIDIA know how to write drivers for CUDA cores. I mean, that's their core business. And it would just be nice to see. I think it would just take it to another market. What are the applications? It depends on what the person wants to do. You can play video on the board perfectly well at the moment, but it would be, you would add video processing capabilities, which, as you can tell, I'm frustrated with the Jetson. It's a brilliant platform for AI, but it could be an even bigger platform. It makes me think of when ASUS launched the Tinkerboard, when they were trying to take on the Raspberry Pi, and they never really succeeded with that in terms of, they just couldn't dislodge it. And I think NVIDIA, if they wanted to, could be one of the biggest players in the home maker enthusiast SBC marketplace with just a bit more software support, because the product is very good. The hardware is very good.
Yes, that is very good feedback. We look forward to seeing more NVIDIAs. Yeah. Yes, so there is another very interesting application. So actually, the last year we also released a board called Jetson Mate that can attach to 4 Jetson Nano or Xavier SOMs together on one board to make it a compact cluster, just the same size as the ODYSSEY Blue. That is a really compact size. So, but we're also seeing some other boards that is for Raspberry Pi clusters. So, for example, Jeff Jerling, he has used a carrier board that can attach. I remember that should be 7 or 8 Raspberry Pi 4 on there. And also we were seeing the carrier boards just can take more, or it can be layered together for a Raspberry Pi cluster. So I want to know, what is a Raspberry Pi cluster used for? What kind of applications it can do?
That's a good question. I must admit, I've never got into clusters, but they do fascinate me. I mean, a cluster is basically taking lots of individual boards and using their power together. So for something like, say, machine learning, that can have application. I think at the moment, and I was talking to someone about this not that long ago, actually, that one of the applications of clusters really is to allow people to learn about that type of infrastructure, that type of hardware configuration, because it's the same thing you get if you're building a supercomputer or something like that. So I think at the moment, cluster computing is something that most people haven't got access to in their daily life. You can't easily go and walk into a store and buy a small cluster computer to actually experiment. And yet you can use SBCs to build yourself a small cluster computer. And I think that's, at the moment, it's an enthusiast thing. It's an educational thing. I can't personally think of why I would need a cluster, but I can imagine at some point I might build one anyway out of a few boards just to experiment with it. And we're back to makers using single board computers as a means of learning and education. And I think that's at the moment, the power of the cluster, because if you want a lot of computer power, there are, in most cases, better ways to do it, but maybe not as interesting ways to do it, and ways that you learn from in that way.
Yeah.
Okay, cool.
And I also think that having a cluster would be equal to having maybe like a desktop PC, like the computing power when we compare.
Yes.
Yeah?
If you want to say, I want to do everything on a Pi, let's have a cluster of 8 Pi, 16 Pis. As you say, you could get the same equivalent power. It's not the most efficient way to do it, but it's a very interesting way to do it, isn't it?
I want to learn about another very interesting topic, is that the RISC-V, because RISC-V is, I think back to the 2019, that is also under my radar. Yeah, so, and also I have seen your 2022 updates. You mentioned covered a lot on RISC-V SBC. But what do you think that? Yeah.
I think 2023 is going to be a very interesting year for RISC-V. There are different views in the industry about how important it is. I think that what Star 5 is doing with its new chip, which is and its new Vision 5 2 board, and I think there's a similar one from, is it Pine coming out? There's I've forgotten the name of the SoC, the SoC on their board, but it's got quad core 1.5 gigahertz board with a GPU. So we're going to 2023 is going to be the first year we see a single board computer at around the same price as a Raspberry Pi, at around the same power as a Raspberry Pi, not quite as powerful, but somewhere between a 3 and a 4 probably, becoming available to makers. So makers for the first time, enthusiasts for the first time, will be able to do the sort of things they've done on a Raspberry Pi, if they want to, on a RISC-V board. And that is, I think, a big change for the industry. Now, that doesn't mean that everybody's going to move towards making RISC-V boards, because, of course, ARM is been there for a long time. A lot of ARM technology, very successful, like things like the Jetson Nano. We've just been talking about the Pi is ARM-based. I don't think any of those will change anytime soon. But the opportunity to have another competitor in the marketplace is an interesting one. And I think RISC-V, in part because of technology, but mainly because of geopolitics, is going to become a much more important platform. And RISC-V is already an important platform. There are literally billions of RISC-V microcontrollers in use already. They're sitting inside SSDs, they're sitting inside cameras doing things like face recognition, things like that. Lots of devices have got a bit of RISC-V functionality already. A lot of people's smartphones have got some RISC-V controllers in them. They don't know it, but it's an ARM device, but it's got some RISC-V stuff there. So what's really happening is we're seeing RISC-V moving out potentially of the microcontroller space a bit more into more general computing space. And whether it works, whether it'll take off, will depend on the price it can be delivered for. And it looks to me like 2023 is going to be where we start to see much lower cost RISC-V. I mean, this year when I did my first review of a RISC-V board, it was about $180, and it was less powerful than the Raspberry Pi. And of course, people were going, why would you use that? And the answer was, this is a development board. This is to allow people to develop for this platform. 2023, we'll start saying, you could just use this because it's roughly the same price. The issue will come back to the one we started this conversation with, which is about support, software support, and for the maker community, tutorial support, guides and things. What I've seen so far suggests that's going to be pretty good. But it's very early days. But I like to see new stuff. I think computing always does best when it's always pushing boundaries, trying new things out, and I think it's good for the computing industry. We're seeing a bit of innovation because we've been based around ARM and x86 for a long time now. And, I think there is space for something else to start disrupting things a bit.
Especially the RISC-V software, the ecosystem, and also the applications we're building up with the RISC-V supports. And DS microcontrollers, we have seen a lot. Yeah, that is a great a new rise especially in this year. Yeah. So yeah, I think it's quite good to discuss with you. Here comes my our topic questions actually. So where do you see the SBCs market next year, and especially your expectations? Hardware interfaces, chips, and also their applications. Yeah.
I think we've obviously had a couple of difficult years in terms of technology because of supply chain issues and all that stuff and everything around COVID. I think what we've, in terms of the maker space, and the enthusiast space, what we've seen in the past year or so is there's been quite a lot of more expensive hardware launched, not much more of the Raspberry Pi price type of hardware. And I think there were a lot of makers who have been a bit upset by that because they got used to having, $35, $45 boards. That's where they thought SBCs should be priced. And suddenly there are lots more expensive boards. And there are good reasons to have more expensive boards. A board like the ODYSSEY, if we discussed, you can do a lot more with it. But for makers, the maker community, I think, is much more interested, most of the time anyway, in the lower priced hardware. That's why we've seen a lot of interest around microcontrollers in the last year, as you just mentioned, whether it's a RISC-V microcontroller, whether it's an RP2040 microcontroller, that market is built up in part because we haven't had the supply of lower cost SBCs available. And I think in 2023, the supply of things like the Raspberry Pi will improve significantly, and that will push the market up. And as those boards become available, all the accessories will become much more in demand as well, because obviously when people get the hardware, they want to do things with them. And most of the time, you don't just want a Raspberry Pi, you want all the stuff around the edge. And I know you sell all sorts of things to plug into all this type of stuff. So I think the market will be a buoyant one next year. But I do think it's a point when the industry's got to decide which way it's going to go in terms of that enthusiast marketplace, because I think enthusiast comes back to your very first question to me about what the key features of the board. And whilst in industry, they are about particular technical functionality and they're about reliability and availability and this sort of stuff, for makers, and I see it on my channel all the time, the number one is the price and support. And there is a danger that many of the ARM SBC manufacturers are putting out more and more expensive boards based on more and more powerful chips, which are really interesting, and people want to watch videos about them, but they aren't going to buy them, And I think that's a bit of a danger for the industry. It's got to be careful that it's serving a particular market requirement rather than just pushing up the spec more and more and more and more and more and pricing people out of the market. The Raspberry Pi is still number one because of the price to a large extent. It is support, but the price really, really matters. And I think some manufacturers have lost sight of that.
Yeah, so about the market. So I think for the CPUs, right? So there are like, I think only two players, as I know, like there's the Intel and there's the AMD, right? For the chip. But I think for the X86 market, maybe like new players can come in just specifically to target the SBC market, because the SBCs are using them directly from Intel and from AMD, those chips. But there could be other X86 based chips which are more cheaper for the consumer, right? So I
don't think Intel and AMD will let them do that. I think, and the market's too small. I don't think our new player in terms of processors will be RISC-V. I think that's
Okay, then RISC-V, then RISC-V is something that we can expect in 2023 for SBCs, and what else? So for the SBCs, I think
maybe Raspberry Pi.
Yeah.
We want more Raspberry Pi.
Yeah, we want more Raspberry Pis also.
Yes.
Yeah, that's also something that we are expecting in 2023. Yeah, because
it is. As I say,
they already posted. They are going to have supply more in next year.
Yes. Well, I spoke to Evan Upton yesterday. So I've got a very long interview with Evan posting on Sunday, and we speak a lot about the supply of Raspberry Pi. So there's a lot more than he says in his post on Monday.
Okay,
but,
that's cool.
I think second half of 2023, I think we will see very good Raspberry Pi availability, and that will be good. It'll be good for all of us, won't it? All of us here want to see SBCs as widely available as possible.
Yes. That also allow us more space to manufacture or the full system based on the Raspberry Pi.
Exactly. That's
Maybe can look forward to the box for rotor or for the other industrial use using the Raspberry Pi. Especially, we just released the industrial PLC based on the Raspberry Pi, because we're just seeing the Raspberry Pis will be good fit for the industrial use as a PLC. We might have more series for that product line.
Because we all always try to listen to the market, right? Because we cannot just keep manufacturing products just like that. So we always want to analyze the market and what people want, what they really need. So we really like to hear feedback from the community, and people like you, Chris, we really value all the feedback from you as well, so that we can bring out good products and compelling products for the consumers.
Yeah,
That's
and
right.
you,
It all comes down
Indeed.
to what people want, doesn't it?
Exactly. Yeah.
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 Actually, the Odyssey boards having the 2.5 gigabyte Ethernet. That is, one time I had a discussion with Level 1 Tech and Jeff Gerling, and they just said that, just one feature switch to the 2.5 that might be better, and then we just bring that up. Yeah. And so, so we listen to the community and just quite take actions as we can serve. Yes. So it's a wonderful talk with you. And meanwhile, we have a special unboxing with you for our boards. So later, I will very look forward to your real unbox, and also what do you think for our Odyssey X86 X82 V2 boards. Yeah.
Yes, that'll be coming up on the channel early 2023, I think, won't it? That'll be the successors of this, to see what the new board is like.
Okay, cool. I'm also happy to see you are really using the X86 boards, the Odyssey Blue, that is helping you for a bunch of the applications.
Yeah, it's a board I reach for a lot of the time.
Okay, cool. Thank you. Wonderful.
Yeah, and Chris, and I just saw that your YouTube channel is like 900,000. It's almost 1 million. Maybe like
congratulations.
Big congratulations to you. You might hit 1
Thank
million
you.
very soon. Yeah.
I hope sometime in late 2023 we'll get there, but we will see. You can never take anything for granted in social media, can you? But it's people keep watching, so we'll cross our fingers. More people will subscribe. We'll get to that milestone.
And more people gonna learn better for SBCs. Yeah.
Yeah, absolutely.
Okay. Thank you.